deal with such a problem in the derivatives table. So we can use len by taking len for both sides, by applying len for both sides. So we have len y equals len x to the power x. And from the properties of len, we can put this power behind the len. So we can write len y equals x len x. Now we can find the derivative. Len y, derivative of len y is y prime over y, or you can write 1 over y times y prime as you like. Here we have a product of two functions, so we have to apply the product rule. Derivative of the first times the derivative of the second, x times derivative of the second, the derivative of len x is 1 over x, plus second times derivative of the first, which is 1. Now we have to find y prime. We can simplify the problem here. X times 1 over x equals 1, and we have len x times 1 equals len x. Now find y prime. You can multiply by y, both sides multiply by y both sides to get y prime, as you can see in the last line. Another problem here. If y equals x to the power e power x, find the derivative dy dx of this function. By taking len for both sides, why should we take len for both sides? Because from the rules of len, we can put this power behind the len. So len y equals len x e power e to the power x. We can put the power behind the len. So now the problem is very easy to solve. Now find the derivative. Derivative len y. You can write y prime over y, or you can write 1 over y times y prime, or y prime can be written as dy dx. We have here product of the first, the product rule, product of the first times the second, plus first times the derivative of the second, the derivative of len, which is 1 over x. So we have 1 over y dy dx equals e power x len x plus e power x over x. Now to find dy dx, you can multiply both sides by y, so you can find dy dx equals y times the right hand side. You can substitute this y by x e to the power x. So the final answer is dy dx equals x e to the power x, e power x as a common factor times len x plus 1 over x. Another problem. If y equals 10x to the power 6 squared x, find y prime. As we have a function to the power function, we have no rule in the table of derivatives that can be used to solve this problem and to find the derivative of a function to the power function. So we have a problem with this guy, with this power. We have to put it down. So you have to apply len for both sides, because apply len for both sides. This len, from the properties of len, this power can be dropped down here to be len y equals sec squared behind the len. Put the power behind the len. Sec squared x can be written as sec x all squared len 10x. Now find the derivative. Derivative of len y is y prime over y, and we have here product of two functions, sec squared x and len 10x. So derivative of the first, put the power down and subtract 1 from the power. So put the power down, subtract 1 from the power, so we have sec x to the power 1 times the derivative what inside. Derivative what inside, which is sec, derivative sec is sec x tan x. And now we have to multiply by the second. So derivative of the first, which is 2 sec x sec tan x, times the second, which is len 10x. Again, how can we find derivative of this part? Put the power down, subtract 1 from the power, so we have 2 sec x times the derivative what inside from the table of derivatives, derivative what inside, derivative sec x is sec x tan x, times the second, just copy paste, plus first sec squared times derivative of the second, derivative tan len tan x, derivative len tan x, derivative len function, we have to write 1 over the function times the derivative the function itself. So len tan 1 over tan x times the derivative what inside, derivative of tan, which is sec squared x. Now you can find y prime by multiplying both sides by y. So we have y prime equals y times all this bracket. You can simplify, you can write this y as tan x to the power sec squared x if you want. So we have to apply len when you have a function, power function, to put the power down. And we have another case. If you have more than two terms multiplied by each other, it is better to apply len for both sides. Now, if you apply len for both sides, so we have len y equals len x times x plus 1 times x squared plus 1. And from the properties of len, you can write len first plus len second plus len third. So when you distribute len inside, you have to distribute it with plus. So len x plus len x plus 1 plus x squared plus 1. So because we have three terms multiplied by each other, so you can write len y equals len first plus len second plus len third. Now find the derivative. Derivative of len y is y prime over y. Derivative len x from the table, 1 over x. Derivative len function, 1 over the function, times the derivative what inside, derivative of the function itself. So you have len x plus y is 1 over x plus y times the derivative what inside, which is 1, plus len x squared plus 1. Its derivative is 1 over x squared plus 1 times the derivative what inside, which is 2x. Or you can use the rule len function u equals u prime over u. Len u equals u prime over u. So you have to find the derivative of x squared plus 1, which is 2x. This is u prime. And down here we have x squared plus 1 down. So len x squared plus 1 equals 1 over x squared plus 1 times the derivative of what inside, which is 2x. And now you can find, so we have y prime, you can delete this y by multiplying both sides by y. So we have y prime equals y times this bracket. And you can substitute this y by the function itself, by the given function x times x plus 1 times x squared plus 1. This is y. So we have y prime equals this format. Find dy dx. Here we have three terms multiplied by each other. Now you have to apply len for both sides. Len y equals, the multiplication here will be converted into summation, into plus. So we have len first plus len second plus len third. And also we know that from the previous problems, the power can be written behind the len. So we have power 5 here, you can drop it down here behind the len. And power 10, we can drop it down here behind the len. Now find the derivative. Derivative len y equals y prime over y, or you can write 1 over y times y prime, and this is y prime, dy dx, equals len x plus 1 equals 1 over x plus 1 times the derivative what inside, which is 1. 5, this is 5, len 3x minus 2, len 3x minus 2, len u equals u prime over u. So this is u here, and u prime, it's a derivative what inside, which is 3. Or you can write 1 over 3x minus 2 times the derivative what inside, which is 3. 10 times len x plus 1, derivative len x plus 1 is 1 over x plus 4. Derivative ln x plus 4 is 1 over x plus 4 times the derivative what inside, which is 1. Now we have to find the dy dx, so we have to multiply by y, both sides multiply by y, so we have dy dx equals y times this bracket, and you can substitute this y by these brackets if you want. Here we have x cosine x over x plus 1 sine x. Here we have more than two terms multiplied by each other, or we have a quotient, so it is very hard to use the rules of quotient and the product. So we have to break the complexity of this problem because you have more than two terms multiplied and divide by, so we have to apply ln for both sides. Ln y equals ln first plus ln second, and the division will be converted to be minus ln x plus ln cosine x minus ln x plus 1 minus ln sine x. So the terms of the denominator must be written as, because we have division here, so we have to subtract negative ln x plus 1 minus ln sine x. Again, ln y equals ln first plus ln second. When we deal with the denominator, we have to write minus ln x plus 1 minus ln sine x, minus because we have division here. And now find the derivative. Ln y equals 1 over y times y prime. You can write y prime as dy dx. Ln x, its derivative is 1 over x. Ln cosine, ln u equals u dash u prime over u. So we have cosine u down here and its derivative up, or you can deal it by 1 over cosine times the derivative what inside. Derivative cosine is negative sine x. Minus ln x plus 1, its derivative is 1 over x plus 1. Minus ln sine x is cosine x over sine x, because ln u equals u prime over u. This is u here, and this is its derivative. Or you can say that ln sine x is 1 over sine x times the derivative what inside, which is cosine x. Now multiply both sides by y to get your dy dx, and you can substitute the y by this fraction. So we have to apply ln to break the complexity of the problem, and we have another example here. Find dy dx where y equals e power x times 2x minus 8 to the power 5 cosine x over x plus 1 to the power 10 ln x. Very hard problem if you think that you can use product rule and the quotient rule. So to break the complexity of this problem, because we have more than two terms multiplied by each other, or we have a quotient, so we have to apply ln for both sides. Now we have ln y equals ln first plus ln second plus ln third, and because we have over here minus ln fourth minus ln fifth. So the terms above you have to write to connect them by plus, and the terms below we have to connect them with minus. Here we have ln e power x plus ln 2x minus 8 to the power 5 plus ln cosine x minus ln x plus 1 to the power 10 minus ln x. Now we know that we can write this power behind the ln, we can drop it down, so we can write x ln e, and we know that ln e equals 1, so this term equals x. And now we have here to the power 5, put the power behind the ln, 10, put the power behind the ln. Now find the derivative. Ln y is y prime over y, or 1 over y times y prime. Ln e equals 1, and derivative x equals 1, so we have to write x here, plus 5 ln 2x minus 8, ln u is u prime over u, so you have to copy paste the 2x minus 8 down, and find the derivative of this guy. Derivative 2x minus 8 is 2. plus len cosine, len u prime over u. You have to copy paste this term here and its derivative must be written above. Minus 10 len x plus 1, as usual, 1 over x plus 1, minus len x. Len x is 1 over, len bracket is 1, our len function, 1 over the function times the derivative what inside? Derivative what inside, which is 1 over x. And now we can write y prime by multiplying both sides by y.